With artificial intelligence making a lot of headlines these days, we thought we would check in on other hype-making tech from a few years ago. Is the Internet of Things still a big deal? Are we still looking at a world where everything will be connected, or has the hype died down a little bit? We're going to talk about these things on this episode of Today in Tech. Hi, everybody. Welcome to Today in Tech. I'm Keith Shaw. Joining me on the show today is David Howard. He is the Director of Technical Sales at Quectel. Welcome to the show, David.
Hi, nice to be here.
David, tell me a little bit about Quectel, what they do, how you're involved in this whole Internet of Things discussion.
Sure. So Quectel is a cellular Wi-Fi and Bluetooth module maker. They basically integrate chipsets from a variety of different companies like Qualcomm, Sony, MediaTek into easy-to-use modules that are pre-certified so that people can incorporate them in their Internet of Things devices, and virtually everything from trackers to vehicles to body armor to cameras, right? So, and as well as Wi-Fi routers and things like that.
All right. So
and I came out of
go ahead.
I came out of the IoT industry, industrial IoT industry, Silver Spring Networks and Itron, doing like gas, water, electric meters, city IoT, street lighting, traffic lighting, all the controls for that. So been in the IoT industry for, wow, at least 20 years.
Okay. So let's just jump right in with the big question is, do you feel like IoT has delivered on its early promises from, I mean, we might be going back at least a decade now with all the IoT hype that came out of a lot of different markets. Has it lived up to the hype, or are we seeing cycles? Where do you feel IoT is these days?
Yeah, so I think, IoT has always kind of been there, but it was more in a custom private network, kind of proprietary standpoint in the 90s and the 2000s. Really started merging on a standards-based approach in the mid-2000s, and through the 2010s, started heavily moving into the cellular side of it. And I think, in certain areas, IoT has really taken off and is really, kind of the norm. Tag and track, cold chain monitoring, heavy equipment, those sorts of things. There are a number of companies that supply that into that industry, and kind of the logistics industry. And it really, fulfilled a promise there. I think, some of the other areas, maybe not so much, but as you may be aware, even every vehicle today is connected. So IoT is there. It's a little bit in the background, maybe not as sexy as some people think. Another big one is, that I was involved in early on in like the City of Lights, Paris, was street light monitoring and controls. So
right.
Operation and maintenance of very large systems. Getting efficiencies out of those by connecting them.
Right. As we look back at when like a lot of the hype had happened, a lot of this was pre-pandemic. Do you think that had a disruption of some sort, whether it was positive or negative? But we kept hearing a lot of things about smart cities, and everything in cities were going to be connected and everything was going to be integrated. And then boom, the pandemic hits. So a lot of cities didn't see the type of growth I think they were hoping for, because nobody was coming into cities for at least a few years. Did that have a disruption on it?
Yeah, it did. So there's a number of things that just didn't pan out. They probably were getting started, and then suddenly nobody's coming into a city. So having parking solutions and routing solutions for traffic and kiosks for pedestrians and bicycles didn't really materialize. It will come around for sure.
Yeah.
Because there are really good advantages to it. But a lot of IoT happened fairly silently, right? Just didn't hit with a big splash, and people don't know it's there. So I like to look at it like when I do my job right in IoT, people shouldn't really know that I've done anything at all. I mean, you may not be aware, but slowly over the last 8 to 10 years, almost all the street lights in the world are now being monitored and controlled remotely, and nobody really notices. All of your electric, gas, and water meters are all monitored and controlled and doing billing remotely. So there's not a person, reading the numbers anymore. So it's not the fancy, kind of obvious things, but it's all the background and automation that's gone into the background, and then use of that data. That's the part that really didn't take off initially. Is okay, now we have all this data that we're able to collect. What do we actually do with it? How do we use that to improve business or improve efficiency or make things safer or better? And that's just starting to happen now. I think it was, the pandemic did a lot of things, right? It got everybody out of the office and made it very difficult for projects that require kind of hands-on to happen. And put the focus on other things. I mean, one of the biggest things we did during the pandemic time is, all of the vaccines that had to be transported around had to be transported at very specific temperatures, and
right.
that had to be monitored through the supply chain. And all of that was done with cellular IoT, so that people don't realize this, but all that stuff that was being shipped around was actually being tracked and monitored in real time to make sure that it was still good when it got to where it was going, and that was all done using cellular IoT.
Yeah, and so is it fair to say that IoT might be the sexiest non-sexy technology out there, because it's in the background and people don't realize what's going on? And is that an indictment on the amount of hype that was given to it? Maybe it shouldn't have been hyped up that much, or when you hype something up, you expect other results, even though it's probably been working great beyond, in the background.
I think the kind of the personal side of it, where how it touches individuals, was probably overhyped.
Okay.
Right? It's starting to get there now, but even the applications that are happening, again, they're, we've almost heard the hype so long that when they happen, it's like, oh yeah, wow, that's not a big deal, right? So people have, Ring cameras, and they have locks on their homes, and they have, security cameras. All of these are connected via IoT, one way or another, Wi-Fi, cellular, combinations of those. There's even, one fun customer that we that just launched recently, makes like the equivalent of a Fitbit for your dog, plus a tracker. We have companies that do collars for a little more serious, for cattle, right? That they can put up basically geofencing. So it's using satellite communications, cellular communication, and GNSS, along with some sensors, to be able to, track the herd, right? And make sure nothing, goes astray there. So high value assets, whether they're critters or machines, are really all being monitored and tracked for health, and to make they don't end up where they're not supposed to be.
Do you think that we got
kind of in the background?
Yeah. Do you think we got to kind of over that first wave of applications and types of products? We were talking about smart buildings, remote location sensor tracking. Like, you put it, if you have a remote area, you put a water sensor in there, and then it alerts you if there's a flood type of thing, or if the server room gets too hot, things like that. And then once that wave went over, now we're starting to see some of these new ideas. Is that fair to say?
I think that's fair to say. There was some really some low hanging fruit that were really high value, return on investment that got addressed first. And maybe more on what I would call, so the industrial IoT, right? The industrial Internet of Things, that had a really strong business case, associated with them, those happen first.
Yeah.
And those are not the hype, right? Those were not the things that people thought of first when they thought of Internet of Things. So now we're starting to see a little bit of a second wave where there's some really clever things that are happening that are more consumer oriented. But even saying that, right? You remember all the rental bikes and all the e-scooters
Yep.
and things like that. Those were all connected, right? So those were all Internet of Things as well.
Oh, okay. Yeah. I think when we talked before the show, you also mentioned another thing that a lot of people don't realize is IoT connected would be like a point of sale terminal. Like if you're at a restaurant and they
Sure.
bring the register over to you instead of having to wait to cash your checkout, things like that, right?
Correct. So that's something that happened, again, the pandemic kind of pushed this along. All the outdoor eating,
Right.
all the kind of contactless sort of transactions that had to take place. Yeah, basically all point of sale now is wireless, right? And it's all Internet of Things. It's all, there was some maturity that had to come to that first in terms of, how do we secure it? How do we, test and put processes in place and certifications in place to make sure that the transactions are, can't be spoofed or hacked and things like that. So there's a whole, standards industry around that as well. But that essentially enabled all of the remote kind of, cashless transactions.
Yeah. Yeah. We talk a lot about the successes of IoT, but have you? I think you and I have a couple of different opinions on where it has not succeeded or where there still needs to be work done. Let's not call it a failure, but maybe some areas where they still need improvement. My example from the consumer side would be this whole internet connected refrigerator that every year you hear about a hype and I think from that standpoint, it's just consumers don't care about that kind of stuff. Like they just don't need to know what's in their fridge, or they've figured out ways to figure that out.
Yeah, I mean, it's interesting because there are a lot of applications like that were initially touted as being the next big thing, and they kind of fizzled. And I guess me being kind of my business hat on, it's like what's the return on the spend for that, right?
Yeah.
So what I found, I never understood what the point of Alexa was initially, right? I ended up getting one just recently, like a year or two ago, and I got it for a different reason. I had to have it for my lab because I was testing Amazon Sidewalk, which is a service they have. Well, I'm not going to get into that.
Yeah.
But and then I had a couple of Alexas around the house to test this, and I'm like, what are these for? And then I found myself in the kitchen. Always, oh crap, I'm missing this. Alexa, add this to the list. Add that to the list.
Yeah.
Set a timer for this. Remind me in an hour for that. And it's like, I'm like, wow, this is actually quite useful.
But that is never what Amazon, I think, had intended for this smart speaker to be. It's the closest I get to it is a timer, an alarm, and normally I'm just telling it to stop because it beeps when it hears the wrong word, and so I argue with it. And then on occasion, my wife will use it as an actual speaker to listen to some music.
Yeah, I mean, very occasionally I'll use it for music just to find something for me or whatever. But the interesting point there is I don't need a refrigerator to have that kind of intelligence because I have the utility that I get out of it. Give me a recipe for this. Give me, put this on my list for shopping. I'm getting out of a different device.
Yeah.
Right. That's hands-free and I don't have to carry it around with me and that sort of thing. So I don't know how, until there's like a killer app for a refrigerator or or for an oven or a stove or a dishwasher or a washing machine. I don't know if that's ever going to be the thing that takes off. Now, if there was on the industrial side, a lot of this stuff comes down to just operation and maintenance. How do you make sure that things are maintained, that they're functional, that they're not about to fail, catch it before it fails. So on that, on a commercial or an industrial scale, I think, many of those things are possible.
Yeah.
HVAC systems, for example, there's all kinds of stuff that's done around those for exactly that purpose.
I wanted to get back.
Level,
I wanted to get back to the room for improvement stuff. You were before the show. We were talking about the eSIM, iSIM issue. Again, without getting too dry, talk about.
Sure. So on the cellular side, the problem always is that you have to have, service, right? So that service has to be arranged with a carrier or a virtual network operator. And it involves a piece of secure silicon called a SIM, right? And the current one is like a little plastic card that someone has to pop out and push in, and it has to be activated and yada yada yada. So the cellular phone industry, because they're monstrous and because that was such a pain in the neck, really, pushed on GSMA and the rest of the carriers, the industry, and came up with a consumer way of basically initializing the service or the SIM with some user interaction, through a QR code, right? And so you didn't have to sell something that was already, had service already with it connected to a specific carrier. You could just sell one device that would work on anything, and then commission it as you were using it, or provision it as you were using it. There's a similar approach that's coming, but still not quite there for machine to machine and IoT, so that you can essentially have manufacturers or OEMs build devices that'll work on any carrier anywhere in the world, and you don't have to know in advance which carrier or service it's going to be on, and you don't have to have a slot to plug a SIM in, and that the end user has to arrange all that after the fact. And that's what eSIM and iSIM are. eSIM is basically a physical chip instead of the little card that's put right on the circuit board or inside the device. But for all practical purposes, essentially the same as a SIM at that point. And then iSIM is actually, let's reduce the cost a little more. Let's get rid of the physical chip, and since we already have a processor and it has secure element or secure section in it, we'll just run it as software inside the device, and so that takes a little cost out, makes it a little more robust from a physical standpoint, and offers the same capability of being able to have a bootstrap profile that goes to one carrier and change it later on. Of course, the carriers aren't really too keen on that because they don't want people switching back and forth all the time with whatever deal is out this week.
Yeah, that's what I was going to ask was, do you feel like that there would be cooperation between carriers and the industry to move towards that model, or is the carriers going to hold it up because of the potential for the switching?
They've already held it up, right?
Okay.
There was a lot of standardization going on during prior to COVID.
Yeah.
The other thing that happened during COVID is it basically shut down all the standards bodies, right? Because nobody was meeting anymore. It was all remote kind of work being done on the standards. And honestly, that's great that it continued, but it delayed everything. There was no plug fests. There was no testing. There was no kind of hands-on back and forth to push things from a concept to a proof of concept to a pilot to a production, right?
Yeah.
And so a lot of things were delayed, and part of that was this, this idea of the IoT style remote SIM provisioning, which is needed.
Have you seen that kind of rebooted?
It has rebooted.
Yeah.
There is a fairly big push to it, primarily because people. Earlier on in the cellular industry, in the 2000s and the 2010s, cellular communication or modules were generally built for specific regions, right? Because the bands are different. There's different requirements from carriers, things like that. And so it was a lot cheaper to build like a North America version a Europe version, South America version,
Right.
et cetera. Right. But with Cat-M and Cat-NB, which are kind of the IoT type communication, it became easier to make global modules that were cheap. And everybody wants to, and there's other ones that are like that too in the Cat 1 and 4 category. But everybody wants to have a single SKU because through this supply chain crisis, the hardest thing to do was to manage like multiple versions of the same thing and have all the different parts, and you didn't want to have stock sitting around and things of that nature. It's not build to order anymore. It was hard to get things. And so single SKU became very important. Build a device, have one SKU for the world, and send it wherever it's going to go, and then provision it there. And so the remote SIM provisioning, plus the ability to build hardware and software that would work in multiple regions has become really important. And that's kind of what's pushing that remote SIM provisioning thing.
Do you have an estimation on when, companies might be able to take advantage of this kind of stuff? Or is this like, a couple of years, 5 years, 10 years? Like how long is this? Do you think this will?
So you can do it today through several big MVNOs, mobile virtual operators.
Yep.
They basically handle the arrangements, and they have agreements in place so they can put localized profiles in depending on where it goes. The ability for the OEM to do it, I think is probably, it's technically feasible today. It's hard to get the agreements with the operators. But I think it's coming. I think it's still, a year or 18 months away before it's kind of, the norm way of doing it, but it will become the norm, right? It will get to a point where devices are basically built, tested, and then shipped to wherever they're going to be used and remotely provisioned. And it makes sense from a cost, a reliability standpoint, and the carriers are they're getting on board. A lot of it had to do with making sure that it was absolutely secure, and the connections could be validated, and there's a lot of detail in there, right? Because the actual cellular modules, they don't manage the connection to the network, the attachment. That's between the SIM OS or the SIM, right, and the actual carrier.
I wanted to ask another question about speaking of carriers and networks. While all of this is going on, you still have carriers that are developing faster networks, and you start going, again, from 2G, 3G, 4G, LTE, all of this stuff. We're now in the 5G world. We're eventually going to hit 6G. As the carriers grow their own networks, what happens to those older networks? They still exist, and that should be a benefit for IoT, right?
Yeah. Traditionally, what happened, in the 1G, 2G, 3G kind of arena, is they had to sunset so those networks because the radio technology and the kind of back office or the network technology was so different that they couldn't coexist, right? So you either use one or the other.
Okay.
Now at there was concern between 4G and 5G that would be the case as well, and that they would have to dedicate, spectrum and or physical infrastructure for either 4G or 5G. As it turns out, on the network side, on the the hardwired side, the transition from 4G to 5G actually uses the 4G network. And that's something called non-NSA or and then there's SA, which is pure 5G. So they can actually virtualize 4G on a 5G network. And so it's not as clear that 4G is going to go away like a light switch like 2G or 3G had to do.
Right.
And the other piece of it is that for the low speed, for the IoT side, they've already kind of written in the LTE based Cat-M and Cat-NB into the 5G standards. So those will carry over.
Okay, so there's not a case where you do this big deployment and then all of a sudden the network goes away. That's not going to be an issue for anybody.
Yeah, and that got driven a lot by the utilities, right? So what happened is, in order for a utility to deploy like a metering structure, to millions and millions of electric meters and gas and water meters, those things have to stay out there for like 15 or 20 years. They don't get replaced at any short interval.
Right.
And so they basically made sure that they would be able to run Cat-M or Cat-NB, well into the 2030s. Now, the capacity of those networks, may go down. There's certainly a push to, use some of the spectrum, some of the prime spectrum for 5G and for the high speed. What they end up doing in LTE Advanced and 5G is they do something called carrier aggregation, where they actually use multiple carriers at the same time.
Yeah.
And they can even be in separate bands, right? They could be some in the low band, some in the high band, a mix, depending on, what's available and what kind of speeds you need. But there is some concern that, like an LTE Advanced, that maybe they don't have the bands available anymore because they've been completely farmed for 5G new radio. But again, it's, we're well into the 2030s before anything like that is looks like it's going to be an issue. And we haven't got any indication that they're going to be shutting down LTE anytime soon. Do
you see a lot of IoT applications that require high capacity and high bandwidth, or is it more of a low bandwidth? Like these sensors, they don't require a lot of capacity, but then maybe I'm just thinking that something that needs a high capacity and high bandwidth, like an autonomous car. Like I don't think of that as an IoT thing, and maybe that's just on me. But like IoT covers that whole spectrum, right?
It does, yeah. So there are some IoT applications that use broadband connections, but typically the broadband stuff is the internet routers, and they might be carrying streaming video or streaming telemetry. However, things like industrial robots, those are very high speed, very low latency, so they require 5G. They need the ultra reliable, very low latency broadband connections for the vision on the cameras,
right,
and the operation of the robots themselves.
And that's where you see edge scenarios, right?
Yeah.
Yeah.
Exactly.
Okay.
Cars are IoT too. All right. And
what is? I'm sorry, I didn't catch that.
Cars are getting IoT as well. I think when we get closer to more autonomy in driving and for safety, and there's vehicle to vehicle communication, which is coming. There's a need for fairly high speed, low latency communication there as well.
Okay, so I want to ask about the future of IoT. If you put your your little wizard hat on or your crystal ball here, do you feel like the IoT is going to you're just going to see more and more devices that will be IoT enabled, or do you see maybe IoT being used in places where connectivity currently doesn't exist, or is it going to be both? You're going to start seeing both, more deployments of things, but also more deployments of locations, I guess would be the term to use.
Yeah, I think it's a little of both. I think there's a hurdle that's just now being addressed on the IoT side, which is, people who are making devices, they may not be very expert at the wireless communication and cellular networks and things like that. So there's a push to kind of make the experience of employing an IoT enabling communication device into your device easier, right? So the cloud connectivity, The guys writing applications, they don't really know about end devices or wireless communication. They just want their data, right? And the ones making devices, they don't really know much about cloud. So the devices in the middle that are actually doing that connectivity need to get simpler. They need to have standard protocols and standard security to allow more companies and more people to develop their ideas without having to be experts at PKI and security and
right.
protocols and all of the other esoteric details in between, and that's starting to happen. It's still a ways away to, that's kind of what Amazon Sidewalk was about, right? Was to make it very plug and play, right? So they didn't have to know how to commission things. They could just turn it on and have it work. And, data shows up in IoT Hub. Similar kind of approach needs to happen on the cellular side for IoT to really simplify the experience so that more dreamers can get out there and come up with the next great thing and not have to struggle with the details of the pieces in between.
Right. No, and what about location-based IoT type of applications? I think when we talked before the show, you had mentioned oceans, very, very remote areas, connecting to satellite connectivity, that kind of thing.
Yeah. So the cellular industry, 3GPP, has added now in release 17 and 18 the capability of doing satellite communications off of Cat-M and Cat-NB. And, there are some products out today and there's some services available with the geosynchronous satellite constellation. So they could be global. They can be truly global, but very low speed, very small payloads, little expensive for the data. But, if you're in an area where there's no cellular coverage, being able to send a message, some kilobytes of data via satellite is attractive. I think the main push is going to be to have these dual mode kind of systems that do terrestrial networks as well as non-terrestrial networks. And I would suspect over the next 18 to 24 months, targeting the low Earth orbiting satellites like SpaceX and others is really going to become the ticket because you get better. One of the problems with geosynchronous satellites is they're over the equator. Mm-hmm. So if you got something blocking between a building or a hill between you and the 22,000 mile high or whatever, I think that's how high they are, something like that. Geosynchronous satellite. That could be an issue, whereas the LEOs are like a cloud around the Earth. And, if you're shadowed on one side, you're connecting on the other. So probably better coverage that way. They're much lower to the ground, 100 miles or 200 miles instead of 22,000. So potentially, a little bit better throughput on it. But those are still, a twinkle in, twinkle in your eye at this point. They're not done. So the Geo satellite constellation and products are available today.
Yeah. So overall, are you generally optimistic about where the IoT space is, heading? Will we ever see this type of hype again, or is everyone pretty much happy, kind of staying in the background and just growing that way?
I think it's getting to the it's getting into its teenage and 20s years. Right?
There you go.
So the hype may have died down some, but it's a super viable area and has a lot of growth in front of it. There's going to be some interesting things that happen over the next 5 to 10 years. In the IoT space, and particularly with the amount of, the combination of like compute and communication and positioning and sensors that can be, smashed down into things like the Qualcomm Snapdragon and the MediaTek smart modules as well, or smart processors.
All right.
That combine all that together.
Yeah.
Because now you've got the capability of doing machine learning and AI on local data that you're collecting at high speed and communicating, peer to peer as well as peer to cloud. I think there's a lot of new applications. I mean, we're seeing stuff in smart ag with like autonomous tractors and things like that are pretty amazing.
Yeah,
right?
yeah.
The local information they can pull in, the processing they can do from their video and other sensors, and then the communications.
I thought we were going to be able to get to the whole episode without mentioning AI, and you snuck it in right there at the end. We're going to have to.
It's definitely happening.
Yeah,
right?
We're going to have you come back, and we'll talk all about AI integration into a lot of these things. Because I would imagine that we would need another episode for that. David, thanks for joining us on the show and giving us an update on IoT things.
All right. Thank you.
All right. That's all the time we have for today's episode. Don't forget to like the video, subscribe to the channel, add any thoughts you have below. Join us every new week for new episodes of Today in Tech. I'm Keith Shaw. Thanks for watching.